Hey friends, so today we're talking about extracellular polymeric substances. A little bit of a mouthful. So let's try to see. Hold on, let me just get my timer going. Hey Siri, set a timer for 14 minutes.
14 minutes starting now.
So the extracellular polymeric substances, or EPS, are natural polymers. Okay, so natural polymers. So I guess another word for them would be a biopolymer. And these are natural polymers produced by the cells of living organisms. So we have we're multicellular organisms. There are, unicellular organisms, and some of them produce these biopolymers. So like other polymers, biopolymers consist of monomeric units that are covalently bonded in chains to form large molecules. Just have a look at that really fast. So covalent bonded, we're reminded that a covalent bond is a chemical bond that involves the sharing of electrons to form the electron pairs between atoms. These electron pairs are known as a shared pair. What is a monomeric? A monomer is a molecule that can react together with another monomer. So we have these monomers that are bounded by covalent bonds, and they're produced by living organisms, by the cells of living organisms. So they're natural polymers of a high molecular weight. They're secreted by microorganisms into the environment. Microorganisms, or microbes, is an organism of a microscopic size, which may exist as a single cell or as a colony of cells. Interesting. So the EPS establish the functionality and structural integrity of biofilms. So a biofilm is a syntrophic, syntrophic is a category of relationship between organisms. So I think syntrophic is one that supports both organisms. I think. So a biofilm is a syntrophic community of microorganisms in which cells stick to each other and are often also to a surface. Stick together, guys, just like a biofilm. So they have the structural integrity of biofilms and are considered the fundamental component that determines the physicochemical properties of a biofilm. EPS in the matrix of biofilms provides a compositional support and protection of microbial communities from the harsh environments. Components of EPS can be of different classes of polysaccharides, lipids, nucleic acids, proteins, lipopolysaccharides, and minerals. Okay, a lot of words there. All right, so let's just see. What are the components? So the components are mostly EPS are mostly composed of polysaccharides or exopolysaccharides and proteins. So polysaccharides are polycarbohydrates. So multi-carbohydrates. And they're the most abundant carbohydrates found in food. They are long-chain polymeric carbohydrates composed of monosaccharide units bound together by a glycosidic linkage. Okay, without getting too much into that. So these are polysaccharides and proteins. So proteins, again, these are large biomolecules and macromolecules that comprise one or more long chains of amino acids. So amino acids are things like, so there are over 500 amino acids that are in nature. And I think they're so they're different organic compounds, okay? It's a type of organic compound. An amino acid, so amino acid is a type of, let's go back one more. So the proteins, they're biomolecules and macromolecules that are comprised of one or more long chains of amino acids and residues. So these are so EPS is mostly comprised of polysaccharides and proteins, but include other macromolecules such as DNA, lipids, and humic substances. EPS are the construction material of bacterial settlements and either remain attached to the cell's outer surface or are secreted into the growth medium. These compounds are important in biofilm formation and cells' attachment to surfaces. EPS constitute 50% to 90% of a biofilm's total organic matter. Let's see. So biofilm has its own wonderful Wikipedia page. So maybe we'll check that out in a different video. What else can we discover and explore here? Let's look at some cool pictures. So I think the green are the microbes. It seems like this is biofilm formation. It's kind of fingering out into this void. And then within it, we have the extracellular polymeric substance. It's this thing, the EPS matrix. So what's the conditioning film? Let's see if it says anything about that, because I didn't hear about that in the intro paragraph. That seems to be a polysaccharide. I'm not sure. So let's see let's keep looking here. Let's see about the uses of this stuff. So far, biomass-based production of industrial microalgae has been widely applied in the field from food and feed to high-value chemicals for pharmaceutical and ecological applications. Although the commercial cultivation of microalgae became increasingly popular, only algal biomass is produced to current products, while huge volumes of algae-free media are exploited in flow-through cultures and after biomass harvesting of batch cultures. Medium recycling to save culturing costs face the big risk of growth inhibition. High volumes of spent media give rise to environmental pollution and cost of water and nutrition supply in cultivation when the media are discarded directly into the environment. Therefore, the application of recycling methods motivated by the simultaneous generation of high-value products from spent medium bears potential in commercial environmental perspectives. All right, let's go into this. Let's go into the ecology section. Oops, didn't mean to edit. Did not mean to edit. So, exopolysaccharides can facilitate the attachment, of nitrogen-fixing bacteria. So this is really cool, and it brought us into something cool. So, diazotrophs. So, as we know, the atmosphere that we breathe is something like 21% oxygen and 79% nitrogen. And nitrogen is really important for us, for organisms, because our DNA is comprised of nitrogen, if I'm not mistaken, for example, among other things. And then the question is, how do organisms get this nitrogen? We need it, right? We need it in our bodies. And if it's in the air, we can't just breathe it in. When we breathe it in, we're using the oxygen, not the nitrogen. So the way we get our nitrogen is through diazotrophs. These are organisms that are capable of fixing nitrogen. Dinitrogen is N2, it's what's in the atmosphere, and these diazotrophs can convert dinitrogen into ammonia. Okay, and that can be used by plants, I think, if I'm not mistaken. And really important, it's part of something that's called the nitrogen cycle. So exopolysaccharides facilitate the freaking attachment of the nitrogen fixing bacteria. So I reckon these bacteria, they secrete these exopolysaccharides. It mediates a symbiotic relationship. Well, we got Nemo and the coral reef. They're the sea anemone, and they see that they help each other out. One protects the other, and they are in symbiosis. This is important for colonization of roots and the rhizosphere, which is a key component of soil food webs and nutrient cycling in ecosystems. It also allows for successful invasion and infection of the host plant. Bacterial extracellular polymeric substances can aid in bioremediation of heavy metals, as they have the capability to adsorb, so they can just kind of stick to metal cations, among other dissolved substances. This can be useful in the treatment of wastewater systems, as biofilms are able to bind to and remove metals such as copper, lead, nickel, cadmium. Amazing. I'm going to end it right here. There's a lot more to discover. This was just a good primer for me because I needed to read about this a little bit. Something just happened. We had a power outage. Anyways, please subscribe. Do we have power back? Yep, power is back. So, please subscribe to the Wikipedia tribe. So I forgot the R. Dang it. Forgot the R. Anyways, subscribe to my channel. I need your support, and it really helps me. So, thanks a ton for watching, and I hope you stay tuned for new ones. Wiki with me is signing out.